Morning all. I welcome you all for today's session. Today we are going to see RL series circuit. So for the past last year classes we have discussed R, L and C individually, that is pure inductor, pure resistor and pure capacitors we have discussed. So the next one is RL series, which means resistance and inductor are connected in series. We are giving the supply, what will happen, and the advantages, disadvantages and applications we have to discuss. And the recall of the session is what is resistance, inductance and capacitance, and also what will happen, the current flow through the coil. I think for the last class we have discussed everything. And inductance, it stores the energy in the form of magnetic field, and capacitors store the energy in the form of magnetic electric field. And the resistance, it, already we know that it is resistor, well, a flow of current, right? So today we are going to discuss understand of RL series circuit, analyze the voltage and the current relationship, and steady state response of this, and phasor diagram, vector diagram, and along with the power calculations and the real time applications. So today we are going to discuss these topics. And next we have to see the RL series circuit. So the circuit shows R and L are connected in series, and we are giving the supply uh, for the circuit, that we consider as V is equal to Vm sin omega t. Along the, if you are giving the supply, the current will be flow through the resistance and capacitance. So the current flow through the resistance and capacitance are same. That's why it's called as a series circuit. And definitely we know that the voltage will be differ. So based on this, here we are mentioning the voltage occur in the resistance is VR and the L is VL, and totally VR plus VL is equal to V. At V is equal to, we are considering Vm sin omega t, where VR is the voltage across the resistor and VL is voltage across the inductor, and the total voltage is circuit, that we consider the V, right? So simply we have to remember what is meant by inductor. So inductor is the pure resistance and pure inductor are connected together. We are providing RL series. So what is the unit for inductor? Yes, of course it is the Henry. Very good. And then if you are applying the AC voltage, what will happen? The current will be flow through the inductor and the resistor, and the voltage will be VR and VL. Then this is the phasor diagram of RL series circuit. So if you are that is R and L are connected in series, we are giving the supply, and the VL is equal to VC. And normally we know that the current is a reference voltage, the voltage will be in phase. So for the resistance, the current and voltage are in phase, and the voltage where the current XL is 90 degree perpendicular to the voltage, and we are connecting these two, we are getting the voltage of total voltage. And this is a diagram for RL series circuit. And RL series circuit, here we are considering current is the reference, and voltage VR is in phase, and the VL is 90 degree, and adding these two values are called as the I into Z, that we call to V. And this is a phasor diagram step draw, already we are discussed. And V is equal to root of VR squared plus VL squared, which is equal to IR squared plus IL squared. So solving this equation, I is equal to V by Z, and Z is equal to R squared plus XL squared. So RLS series in the circuit is called as the impedance, and is measured in the ohms. And this is the phase angle between what is meant by phase angle? The current and the angle between voltage and current we consider as the phase angle. So we have to mention in the letter pi is equal to tan inverse of XL by R. We'll get it from the phase angle circuit. And this is the phasor diagram of that is we are giving the Vm sin omega t. We are mentioning in the solid line, and Im sin omega t minus pi, it is a lagging power factor. This angle 90 degree, and it is which is mentioned in the dotted line. and this is the power for calculation. First we are considering the Vm sin omega t is the equation number 1, I is equal to Im sin omega t minus phi is the equation number 2, and P we know that P is equal to Vi. So P is equal to Vi, we have to multiple, and solving these equations we will get the power is equal to P is equal to I squared R. This is the equation of that is I squared R means it is the power dissipation equation, and also we have P is equal to Vi cos phi. This is the equation we are getting. So, and we are based on this we are draw the equation waveforms for P, V and I. That is voltage is measured on the yellow color, and the current is measured in the form of red color, and finally we will get it power is in the magenta color, right? So I think you'll learn more. This is the define and the empathize, and the applications are choke transformers, motors, and the power factor corrections. And the summarize of this session, we are discussed what is the inductor and the RL, how we are connecting RL and the RLs, we are going the supply and the phasor diagram and the equation of power. And these are the reference for the reference. Thank you.